5, 4, 3, 2, 1. Okay, so in this next lab, actually starting off with the same configuration environment that was used for the RIP-NG, which is 3 routers, router 1, router 2, and router 2, and router 3. The interfaces on all the routers, including the loopback interfaces, have all been configured. Once I learned how to configure interfaces, I don't cover that in my review because it's pretty straightforward. So what we'll do though is show IP interfaces brief to confirm that the interfaces are all in the status of up and the protocol up. So all the serial interfaces are up there, as well as the loopback interfaces. Loopback interfaces auto-magically go up as soon as they're configured. Let's take a look on router 2. Show IP interface brief. And again, the serial interfaces on router 2 are in the status up and protocol up, as well as the loopback interfaces. And on router 3, the serial interfaces status up and up and protocol. So we're set there on the interface. And what's going to happen here is on router 1, I'm going to configure EIGRP, and then we're going to turn on some debug messages and see what's happening. If I get to see do I get to see anything that helps me in troubleshooting? Have I configured it correctly or not? So let's start on router 1. Go into global configuration mode, and the configuration for RIP and EIGRP, all of them all start, well, almost all start with the command of router, and we see there the protocols, and we're going for EIGRP. And then we need to provide it either an autonomous system number or an EIGRP virtual instance name. Virtual instance will be in a subsequent session, not this one. We're just going to focus it just now on autonomous systems. So we're going to give this an autonomous system of 100. And then on router 1, I'm going to configure a really loose network statement. Network statement is going to say how loose. Do I want to go really loose? I'm going to go really loose, and I'm just going to say on all interfaces, on all the interfaces. No, let's see. We're going to say 10.0.0.0, and then we're going to back up. And we say debug IP EIGRP 100 and debug IP EIGRP neighbor. Wait just a couple of seconds. Do we see anything? Nothing. So even though I've configured the router EIGRP 100 statement and the network statement, nothing's happening in the debug. However, if I look at that just on the surface, nothing is happening. But in fact, there's something that's already going on. So we're going to let's take a look at start a capture, and we're going to do a capture from router 1. Router 1 HDLC. It's going to probably come up on another window. If it does, I'll just move it over. Yeah, it did. It's just as I thought. It brought it up on another window. So what interesting. Right now, already, we see, I think I've got enough, so I'm going to go ahead and stop it. Let me move down so we see the last one. So already, as a consequence of the router EIGRP 100 statement and setting up the network. As soon as the network statement was defined, the EIGRP process started sending out an EIGRP hello message. And we can take a look at that. So we get a real good look here. It's real simple in terms of the first pass. It's not going to go too deep, but we see that that protocol is EIGRP 88. Is there anything else? Yeah. Look at the source. The source is showing router 1's serial interface, 10.1.102.1, but notice the destination, 224.0.0.10. It's a multicast. And unlike my previous session with RipNG, which continues to, no, not RipNG, but RIP broadcasting out, we're now moving into multicast space. So EIGRP is specifically sending out to the multicast address of 224.0.0.10. And interestingly enough, it's sending out, and of course there's nothing coming back from router 2 at this point because router 2 hasn't been configured. So I'm going to cancel without saving that session. Bring up another session. Oh, I keep forgetting. I have to stop the capture and start a capture again. So we're going to do router 1 HDLC. Yeah, I know what that's about, so don't worry about that. So what I'm going to do now is very quickly jump onto router 2 and going to go into the global configuration mode and router EIGRP 100. Oops. Slow down. EIGRP 100. And we're going to give it a network statement of 10.1.0.0. 0.0.255.255. This is a wildcard mask. Let me back up so we see that this is not a subnet mask. This is a wildcard mask, and it's different syntax, and we'll be looking at that syntax in a moment. Okay. And immediately we have an adjacency. Now what I want to do is I want to go back to the wire capture. Oh, beautiful, 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 beautiful. So I'm going to stop that session, and I'm actually going to fill the window there. So as soon as router 1, we saw what router 1, after the network statement was plugged in, that EIGRP protocol started sending out hello messages, but nothing was coming back to it. And then I configured it on router 2, and here we have 102. There we go. And so as soon as router 2 came up, router 2 sent a hello message, and that was all that was required for the adjacency to form, was that hello message from router 2 to router 1, which is right here, this one that's highlighted. Source was 10.1.102.2, and again to the multicast address. And once those two, both router 1, router 2, received their hello message, the adjacency was formed. Then the next message that went from 102, from router 1, was an update message. I should have looked at this from the other side. Should have looked at it with the capture from router 2 to router 1, because then we would have seen the hello message actually going out. But what we see here is in response to the hello message from router 2, router 1 then sends an update message. But notice that the destination is not to the multicast address. The update message is unicast, specifically to 10.102.2. Okay, so there we've got this. So we've got a hello followed by an update, and then the updates are acknowledged with a hello. It's not that there is an update acknowledgement. The update is acknowledged with a hello. So let's take a little, go in there and look a little deeper there. So we have, again, protocol 88. Source is 10.1.102.1. Destination 10.1.102.2, which is router 2. And the EIGRP version 2 is a hello message. But notice it is an pardon me, it is an acknowledgement. So the acknowledgement of an update received in EIGRP is a subsequent hello message that is acknowledging the update. And once the updates are exchanged between the two routers, then dual is run on each router, and the entries that were received in the update, which were then placed in the topology table, and dual runs against the content, the entries that are in the topology table, and specific routes then go into the routing table. Not all routes that are in the topology table, as we'll see, not all routes go into the routing table. So I'm going to go back over here. So we have back on router 1, and now we're going to back up. We're going to look at something here additional. Remember, I turned on debug on router 1, so I'm going to turn debug off. And the debugs that I had turned on were debug IP EIGRP neighbor, debug EIGRP, and the EIGRP process autonomous system 100. So we see here new peer 10.1.102.2, which is router 2. That was as a result of that first exchange of hello messages. And because as a result of that, there is a new adjacency with this new neighbor 10.1.102.2. Then we have the exchange of updates and those resulting those updates going into the topology table. We then have routes resulting from the calculation of dual, and we see specific routes that are going will either end up in the routing table, or they'll just be in the topology table and the topology all links table. So if we look now on router 1 and do a show IP EIGRP neighbor, we see our new neighbor 10.1.102.2. Going to dig a little deeper into the other let's just go ahead and do it now. So we have the serial interface that neighbor 102.2 neighbor was first heard from on serial 1/0. The hold time is 10 seconds. The adjacency has been up for 4 minutes and 21 seconds. The smooth round trip time is 26 microseconds. The round trip timeout 1170. Can't remember if that's microseconds. I think that's microseconds also. We have no updates that are queued, and the sequence number is 3, and that sequence number is used in the database, the topology database, keeping up with the updates that have been received, so that they are to keep track and make absolutely sure that the updates have been entered into the database are the most recent. we'll dig a little deeper in that. But for right now, we just want to take a look at, yes, we've got our neighbor. We've got a neighbor that's showing up, coming in from that serial 1/0 interface. Now we'll take a look at the show IP EIGRP topology. Now this one shows us, this is all, these are the results of the networks that were received as a result of the updates. And this where we're going to start to see the activity that's resulting from dual. I'll be going deeper in that. This command actually, show IP EIGRP, has another word that can be added to it, all links. And in this case, I don't have any networks showing up in the all links that are not in the topology database. Let me make sure. Let's see. Topology has, pardon me, 1, 2, 3, 4, 5, 6, 7, 8, 9. And all links 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are cases where there will be networks present in the all links that are not in the topology table, and those entries that are in the topology table will have arrived there as a consequence of dual activity. So if we then look at show IP route, we see the connected networks as well as D in front of, and dual stands for, D stands for dual here. If we look up in our legend, D is for EIGRP. And let's make that a little more exact. EIGRP, show IP route EIGRP. Now we're seeing only the routes for EIGRP. Okay, so what we've seen is that in a session, I'm going to go ahead and stop this capture, that in a session where EIGRP has been configured on a router, with debug turned on, there appears to be little happening. In fact, as soon as the router protocol, as soon as the router EIGRP autonomous system number is configured, and as well as a network statement, it is the network statement that is critical here, that interface starts sending out hello messages looking for a neighbor to form an adjacency with. And we saw that in the Wireshark capture. As soon as that as soon as that network statement is configured, the hello messages start going out, and there they are at a very clear interval. It's I'm going to change my time here. It's roughly 10 seconds apart. I'm going to change the time on Wireshark so we're actually seeing the system time instead. I'll make sure that's changed for next time. So we have those hello messages going out, and it's those hello messages that between the two routers that once they see each other, that bring about the adjacency. And then following the adjacency, the exchange of updates and acknowledgement of those updates with specific hello messages. Those updates, unlike the hello messages, are unicast. The hello messages are going to the destination of 224.0.0.10, whereas when the updates start, the updates are unicast. We see here on this capture from router 1 to router 2, the source is 10.1.102.1 to the destination of 10.1.102.2. So we transitioned from a multicast for the hello to a unicast address for the updates as well as for the acknowledgments. And I think that's probably a good place to end this one. And the next session, what I'll do is I'm planning to configure two between router 2 and router 3 a default route as well as a static route. Static route, if my memory is correct, will be going from router 3 to router 2, and a default route going from router 2 to router 3. Okay, well, that's that. Until next time. Between router 1 and router 2, so we can confirm that if we do a show IP protocols, and we give a little more space here so we can see. Roll back. So we see as a result of the show IP protocols on router 1 that the routing protocol is EIGRP and the autonomous system is 100. We see the metrics and the K values here. They are all at their default with K1 and K3, K1 being bandwidth and K3 being delay at their default values of 1, and the remainder are all at 0. We see that the router ID was picked from the loopback interfaces. That reminds me. This is something that most likely in production you don't want the system determining your router ID, because if we take a look here, if we do show IP interface brief, we see that the router ID for EIGRP is the highest loopback interface. So there's an order of precedence. So what we actually want to have our router ID be explicit and controlled so that we know. I like to give them names as a numbering that's reflective of the router number if at all possible. So what we'll do is we're going to go back into global configuration, and we'll go into router EIGRP 100. We'll say router ID. What? Oh, I'm forgetting. EIGRP router ID, and I want to give it the number of 1.1.1.1. And what we'll notice is that I've configured something. If I do a show IP protocols, now the router ID has changed to 1.1.1, but it's very important to see that this is not a passive act. The adjacency actually dropped as a result of changing the router ID. So I've heard the phrase used that this is an exit strategy statement, being someone's exiting from the organization where they perform this, because you don't want to do this during the production day. Those networks, that connection between those devices just came down. So that's definitely a change management authorization with a clear indication that when we do change that router ID for a specific purpose being determined, that there is going to be a very short outage for that, and it will impact end users. So so back to let's just show the results. Right, so we're looking again at the output from the show IP protocols. Since EIGRP here is running IPv4, so there's the router ID that we just changed. The active timer is at 3 minutes. Internal administrative distance of 90, external of 170, max path 4. And the variance is set to 1. That variance is something that comes into play later with equal cost load balancing, and how we actually use that to bring about some additional changes with balancing, with using underutilized networks. So we say here that we're routing for the 10.0.0 network. The gateway is 10.1.102.2. Again, administrative distance, and the last update was received 50 seconds ago. And there are our distance internal administratives of internal of 90 and external administrative distance of 170. So what we have there now is we can clearly see that EIGRP is running on router 1 and on router 2, because we see there is that teardown of the peer between router 1 and router 2 when I change that router ID. So let's go ahead and do the same thing here on router 2. Router EIGRP 100, EIGRP router ID 2.2.2, oops, typo, 2.2.2.2. And we'll you see the same thing occur. This is again an action that we want to do when it's scheduled. Show IP protocols, and the router ID is already changed, and we now see the system message there. Did I not say back here line console 0 logging synchronous? I must not have done that. Do the same thing here. Conf line con 0 logging sync. Okay. Logging synchronous changes how the system output information is displayed to screen. If we were to, for instance, back here on router 2, go back into router EIGRP, I'm going to go same process, but I'm going to say give it a different router ID, which I'm going to change back, but 3.3.3. When it actually completes this task and echoes back to the screen the system message, instead of it occurring right in the middle of a command, it displays it out to a clear line and returns us to the point within our command output that we're reading, which is always good for my eyes so that I can see exactly what's going on. Okay, so we've got router 1 and router 2 both with the do show IP route. No, do show IP protocol. Okay, with the router ID that we need there. Actually, we need, that's right, we need to change that. Need to say no and put it back to 2. Okay, so let that take place. Okay, so we got that set there on router 2. And now what we're going to do on router 3, just again, that's just the system message that changing that router ID actually brought down the adjacency, and the adjacency came back up. So here on router 3, we're now going to configure, I'm going to configure RIP. I'm stuck in RIP mode. We're going to configure EIGRP on router 3, and so let's do so we can see again some information. Let's do debug IP routing and debug IP EIGRP 100. Also might take a look at a wire trace. I'm not sure, so let's go into global configuration mode. I'm going to say router EIGRP autonomous system. Now let's try something here and see what happens. I'm going to fat finger this. Instead of typing 100, I'm going to type 101. So on router 3 we have a EIGRP process started with the autonomous system of 101, and then we're going to let's take a look. Start that capture. So we're doing that from router 3. Okay, so we've got those hello messages. So look, now it's interesting. I said earlier that as soon as I configure the network, but it's actually as soon as the protocol, the EIGRP autonomous system number is configured, the EIGRP hello message is already going. So now we're going to go back to router 3 and configure in, see what I was talking about there. So all I've done here is configured the router EIGRP and the autonomous system number on router 3, and we have hello messages already going. I have not configured the network statement, but the hello messages are in fact already going. So now I'll say network 10.0.0.0, and we should get an adjacency between router 3 and router 2. Interesting. We still have the adjacency on router 2 to router 1. So if I do a show IP EIGRP neighbor, I still only have the neighbor relationship between router 1 and router 2. Now if I take a look at the capture, I'm going to actually change this capture. So we looking at this hello message going from router 3 to router 2. It's given the source of router 3's serial interface to that multicast 224.0.0 224.0.0.10, the EIGRP protocol identifier, and we're down here. How is that? Oh, it's okay. It's received a hello. What now? What am I got? Yeah, this is from router. I'm on looking at the capture from router 3, but router 2 is sending hellos to router 3, but nothing is happening. The hellos keep coming. We still do not have the adjacency. So I'm going to stop that one and go back over here, stop that capture. And what I'm trying to see, actually I think I want to go back into router 3, debug IP EIGRP neighbor. Debug IP EIGRP notifications. So what I'm trying to see, and it's escaping me just at the moment. The fact is, the EIGRP autonomous system numbers must match. On router 3, I configured router 3 show IP protocols. Show IP protocol. I configured router 3 with an autonomous system number of 101. Routers 1 and router 2 are autonomous systems 100. So in order for that adjacency to come up, they must agree, all the devices in that autonomous system must agree on the same autonomous system number. So we're going to go in here, go into global config and say no router EIGRP 101. And make it router EIGRP 100 and give it the network 10.0.0.0. And there we go. We've got incredible information there. So if I do show IP EIGRP neighbor, now we have a neighbor relationship between router 3 and router 2. Router 2 is 10.1.203.2, as well as a neighbor relationship with router 1, 10.1.103.1. So we now have around a full network of router EIGRP active sessions, not sessions, active adjacencies between router 1 and router 2, router 2 and router 3, and router 3 to router 1. And the key of this latter part of the exercise was to make sure and drive home that fact that the autonomous system number is key, in that all of the autonomous systems, all the routers that are to participate in a particular autonomous system, kind of seems obvious, must use the same autonomous system number. And what I'm going to check back is I thought there was an actual debug where I can see that autonomous system number being thrown, and on the recipient end saying, disagreeing, not liking it because it was the incorrect number. But so with that, we've got the EIGRP, and I'm going to turn off, do you all turn off debug. And what we're looking is, because of those, the debug IP routing and the debug IP EIGRP, we have, let me back here to the start of this. So as soon as I change that to router EIGRP, after I change that router after configuring EIGRP with the autonomous system number of 100 and providing the network statement of 10.0.0.0, we have the exchange of hello messages, and then the update process, the updates exchange between the routers. Here we see the indication of a new peer between router 3 and router 3 and router 2. Then we see the new adjacency, and we have these are updates. Updates including the EIGRP metric. Then we have the RIB updates, the routing information base updates occurring on router 3 based on the, after dual is running against the contents of the topology table, and we're getting routes actually into the routing table. And I think that's a good place. Let's see, next thing I want to do is go back to router 1, show IP neighbor. Show IP EIGRP neighbor. Okay, so now on router 1 we see both the neighbor adjacency between. Let's see how many, so we can see that. We see the neighbor adjacency between router 1 and router 3, as well as the neighbor adjacency between router 1 and router 2. Again, we see the interface, the hold times, and the uptime for, of course, not of course, the uptime for the adjacency with router 3 is much less than the adjacency between router 2 because it came up later. And here we can see that the order that the adjacencies occurred, the 0 here indicates under the H is that router 2 adjacency came up first, and that router 3's adjacency came up next with the 1. That's what the 1 there indicates. And so we should just do, actually let's stay here. I want to do show IP route, and we have a number of additional entries. We have the loopback interfaces. So all of these are, by doing the EIGR show IP route EIGRP, we're looking exclusively at the routes that have been learned from EIGRP. The 10.1.2 or the loopback interfaces on router 2, and the 10.1.3 are the loopback interfaces on router 3, and the 10.1.203 is the network between router 2 and router 3. So we have a significant important information here that's now been supplied and added to the RIB as a result of dual being run against the content, the database, and the database content and the topology table. So we should now be able to ping 10.1.2.1 to, it should be able to get all of them, 2.5 and 2.9, as well as the loopbacks on router 3, 10.1.3.1 and 3.5 and 3.9. Okay, so we have full connectivity from router 1 to those loopback interfaces, which are emulating or to simulate other networks. So we have good connectivity all around. And let's see, what the next thing I want to do is let's go back to router 3, and let's just show IP route EIGRP. So now here we're seeing the look from router 3. We see the loopback interfaces on router 1 and the loopback interfaces on router 2. And this last one is the network between routers 1 and router 2. Let's do a show IP EIGRP, show IP EIGRP topology. And it's really important here that all of the entries in the topology database have a P for passive. We don't want to see active. Active indicates that it is EIGRP is attempting to find a route. It's still calculating to find a route to that destination. So P is what we always want to see. P is good here. Let's do a show IP EIGRP topo all links. Again, I think I may have mentioned this earlier. It's very possible when looking at all links, the big distinction here now is, since we have connectivity all around, is we have more than one path to specific networks. On router 3, we have a path via router 1 to get to the 10.1.2.8 network, and we have a route via router 2 to get to the 10.1.2.8. But if we look back, let's take a look. Do show IP EIGRP topo and 10.1.2.8/30. What we're looking at now is, by looking at the specific network, we look at the components that went into how the feasible successor and the successors were arrived at. So we're seeing the composite metrics and the values that were included in that calculation. And this brings up something really clear to me. I probably will change in a moment. Is all the links have 128 kilobits, but that's okay. We're okay. So okay, let's see. Um, I think that's what we want. That's it for this point. Well, okay, I know what I can do is, actually, I'm going to cut this one. I'm going to stop here. When I come back, we're going to take, with the next session, we'll take a look at how load sharing for packets occur in EIGRP, and we'll actually do some playing, turning off some of the internal components in the iOS, specifically Ceph, because Ceph has some performs per destination load balancing, and we'll turn that off so that we can allow EIGRP's load balancing. So that's what we'll take up with the next session.